Let's look at graphing absolute value inequalities. When you graph an absolute value inequality, you're going to be sketching a region, not just a point or a line. When you have your function, say y is equal to the absolute value of x, the first thing you need to do is pick your boundary. If you have a greater than or less than, then your boundary is going to be a dotted line. If you have greater than or equal to or less than or equal to, then your boundary is going to be a solid line. What this means for a dotted line is that the equation of the line y equals the absolute value of x is not a solution to the inequality, while the solid line indicates the points along the boundary are indeed a part of the solution. Now, how do you pick the region? Well, here are some steps. The first thing you're going to want to do is solve the equation for y. So you're going to get some sort of inequality, like y is greater than the absolute value of x. Identify the vertex by taking whatever is in the absolute value and set equal to 0. And then identify the slope of the branch. One side's going to be positive, one side's going to be negative. You're going to pick your solid or dashed line depending upon whether you have greater than or equal to, you'll use your dashed, or less than or equal to or greater than or equal to, you'll use a solid line. Finally, you pick a test point. And if the point makes your inequality true, you shade that side of the line. If it makes your equation false, you shade the other side. Let's try one. Suppose I have 1 minus y is less than x plus 2. Well, the first thing I want to do is to solve this. Now, the first thing I note is I'm going to need a dashed line when I graph it. So I'm going to write that up there to remind myself. So let me solve this for y. Let me subtract 1 from both sides. So minus y is less than the absolute value of x plus 2 minus 1. Now I'm going to multiply both sides through by negative 1 to get a positive y. Got a lot of negative 1s there. What that means, remember, I have to switch my sign. So y is going to be greater than, when I distribute this negative sign, minus the absolute value of x plus 2, and then plus 1. Next, I want to find my vertex. To find the vertex, I take what's in the absolute value, and I set it equal to 0. So x is negative 2. After I find the x value of the vertex, I need to go and find the y value. So what is the y value? Y is going to be minus the absolute value of negative 2 plus 1, or see, that's 0, so it's just 1. So I'm going to need to graph the point, negative 2, 1. That is my vertex. Now, this is going to be downward sloping. It is reflected. So remember, you want a dashed line, and it's going to have a slope of minus 1 on this side. So let me get a nice dashed line going here. Use your ruler. I don't have one. Let's see. There you go. You get the idea. There's my dashed line. Now you need to pick a side. You can pick any point you want. I personally like the origin. All right? So I want you to identify the point you're checking. In this case, I'm going to pick the origin. And I'm going to go back up to my original equation and see if it satisfies my original equation. So 1 minus 0, is that less than the absolute value of 0 plus 2? Is 1 less than the absolute value of 2? Is 1 less than 2? Yes. Since it's a solution, what you're going to do is you're going to want to go in and now shade the side that includes the origin. And this is going to be quite a bit. All right, it's kind of fun. So we're not going to include the line, but we're going to include all of the points above the line. Now sometimes I'm going to want you to write an inequality from a graph. The first thing you want to do is find your vertex. That will really help you out quite a bit. The vertex here is at what? 3, negative 2. Now, what that tells you is that you're going to have some sort of absolute value x minus 3. Because when I find the vertex, what I'm trying to do is make whatever is in the absolute value equal to 0. So x minus 3 is equal to 0 when x is equal to 3. So that's how I found that part right there. Now, when x is equal to 3, I want the y to be equal to negative 2. So I'll have the negative 2 out there. And now it's just a matter of, do I want greater than or less than? Obviously it's dotted, so it's got to be greater than or less than, not equal to. And let me look at this. I want the y values that are above this line. Now let me check this. Let me check my test point. Let's pick the origin again. Is 0 greater than the absolute value of 0 minus 3 minus 2? So is 0 greater than the absolute value of negative 3 minus 2? Is 0 greater than 3 minus 2? Is 0 greater than 1? No, it is not true. So I don't want the origin side. I do want the other side. Let me check my lines. These have a slope of 1 and negative 1. And the vertex is at 3, negative 2. Okay. So here is my answer.